Here we can see how to create a customized footprint. So we're gonna create a PCB library. For that we are going file, new, library, PCB library. So we got a sheet where we can create a PCB library. So now we can go for a component wizard, which is in tools, component wizard, so that we can get a component wizard dialog box. We could go through it. Next, now we are going to create a ALtium, which we have lost in the schematic. So we can go for a quad pack and just select the unit in which we are going to do. It's mils imperial or metric mm. So we're gonna for mils or mm metric. Next, so here we can define the patch size. Normally it is given or gone through in the datasheet, so we can just refer the datasheet so that we can give the units and define it as follows. So we could go through as it is. Next, so here we can mention the paths, first path, indicate the first path. Normally the first path should be a round or rectangle. Here we can use it, and the other regular paths. So first we can have an alternative by representing the first path as a rectangle and all the other paths as round. Next, so here the outline width, so we can set the outline width as per the constraints given in the datasheet, and we can go for next. Here are the units which would be calculated in the datasheet or given in the datasheet. Some are given in the datasheet and some could be calculated through the datasheets. So normally we can go for a minimum, or we could keep it as it is in the given in the datasheets and proceed it. So the first pin locations could be shared here by clicking the pin. So if we click here, the first pin starts from here and go on through like that. So here we can set the first pin from here, go for next. So what are the number of pins? So we're gonna create a 64 pin ALtium. So we want to have a 16 pin in each side to get 64, so that we have. So what name should this code have? So we can set it as ALtium AVR, AVR 64, then give it next and finish. Yeah, here we have, this is our footprint where the first pin indicates in the rectangle and all the other paths in the round shape. So we can just check it by measuring the we can measure the space between this, or just click on the path so that we can edit and move for the further changes by the designers. So this is our ALtium footprint, we got it. And the purple color around the pad, which is a solder mark representation, so we can set the solder mark representation as per our constraint from the customer end, or provided from the customer end. So here we can got the footprint ready, and we can just save the footprint as .pcb lib, which is the extension of this footprint. So we can save it as ALtium AVR 64, just for our understanding. Description which is given from the datasheets, so save it as it is. So this we conclude from creating a custom